distribution, polynomial distribution, binomial distribution, then your sigma algebra, Borel Field, sigma algebra, and distribution, distribution, and probability function. Okay, ma, right? These four things. Just a minute. Give me 1 second more. How we will do? Just a minute. Cumulative distribution function. CDF. Three coin. Borel Field. Then Field. Yoga, Borel Field, sigma algebra. Okay, now what I will do? Base theorem, so that also we can explain, right? No problem. But more important than that is explaining your what I'm thinking. Yes. This is binomial. This is Bernoulli. X and X. Okay. Probability. Base also we can discuss. So it will also justify, okay? Base theorem, right? And just remind me, okay, we will take few PYQs as well. 2000, I think 17 was there one PYQ or 17. Then 16 I will see. Paper 2, 16. Okay, 2016 there is a one binomial question. Okay, 2016 question number 1. Just write down. Question number 1B. Okay, this is binomial, and what we will do. Uh, 2012 is there or what? One more question. 2000, I think 10 with that question was there somewhere. I'm not getting that question. Okay, just note down 2009, question number, paper 2, question number 1. Just remind me when I say na, just variable question, so we will discuss this one, right? Question number 1, A part. A part, that is also binomial distribution. So we have noted 2 questions, right? We will discuss that. We will discuss Bayes theorem. We will Bernoulli experiment, this Borel Field, probability function, and PYQs we will take. Okay. Right. Amit, I'm starting, right? No. Welcome everyone. So in today's session, we will discuss some PYQs from probability, and we will discuss about Bernoulli distribution. And we know binomial distribution is mainly derived from Bernoulli distribution. Then maybe something about Bayes theorem. See, binomial distribution and Bayes theorem, these two are very important topic, right? You have seen how many questions every second year you find a question from here. Either from binomial or from Bayes theorem. This is assured. And other than that, I believe you must also know what is Borel Field. See, UPSC will not directly ask what is Borel Field, but this understanding you must have. And Borel Field is also called sigma algebra, and something about a probability function also you must know. So let us start. First you must understand this thing. Let's say you know what is set theory. You simply count set, right? So think like this. This is your set theory. And you know, they were wonderful set theorist, Bertrand Russell and Cantor was a wonderful set theorist. Set theory, see, there are mainly 3 things. Set theory, probability theory, and your statistics. Right. In UPSC, you are asked statistics, both in QAM and OM, and some part in FIN as well, and probability, right? So this is the big picture. Your probability theory was derived from set theory, and the set statistics is a subset of probability theory, right? We cannot discuss all this, but this understanding you must have. Fine. Now you understand things like what is mutually exclusive, what is independent. Let's say when I say A and B are mutually exclusive. A and B are mutually, what it mean? No. How? CL, okay, what I'm writing. Exclusive, just a minute. Exclusive, right? Exclusive. Okay, you are saying when things are mutually exclusive, they are independent. They are independent. No. See, here is a problem. Let's say I toss a coin. Head and tail are mutually exclusive. Any doubt about that? If I get head, I will not get tail. If I get tail, I will not get head. So what indirectly means? They are mutually exclusive. Or you can write it, probability of head intersection tail is what? 0. Right? This is a simple definition of mutually exclusive. But let's say I do a trial. So can you say within that trial, head and tail are independent?
Within the tail it's dependent.
But
another
okay. See, when I say 2 events are independent, for UPSC or for any statistics course or any probability course, you will remember only one thing. What? Probability of A intersection B is equal to probability of A into probability of B. This is the only definition you have to remember. The 2 things are independent. Okay. Now you know conditional. You also know this thing. What is the meaning of this? Probability of A given, probability of A, we call it conditional probability. Probability of A given B, and it is given by probability of B, right? This is a simple definition. Now let us, when I say A and B are independent, what it means? That, the probability of whether B has happened or not, it is not making any difference to A, right? That's the meaning of independent. So can I write equal to probability of A? Can I write this equal to probability of A? Because happening of B or not happening, it is making no difference to, so the probability of A will remain probability of A, right? So if you compare these two things, this equation and that part, what you will write? Probability of A intersection B is equal to probability of A into probability of B. Any doubt about it? So always remember this condition, right? Fine. So you have understood, independence. So when I say, let's say I conducted one trial, I got head. Within that trial, if I have got head, I have not got tail. So this means head and tail are dependent. Within that trial, they are dependent. They are mutually exclusive, but dependent. It is dependent. Let's say I conduct one more trial. So in this trial, I can say the probability of getting head or tail. See, understand this phrase. The probability of getting head or tail in the second trial is independent of the first trial. And that is the assumption which flows into binomial distribution, exponential distribution everywhere, right? We assume that two trials are independent. But within one trial, the two outcomes are dependent. Very, very, very fine thought. But you must know, keep this in your mind. Any problem?
No, sir.
Okay, now this is fine. Okay, now let me define what you can do. You know things like set. Okay, let's say a set of let's say a student in one class, maybe 10 students, right? This is called set. Empty set, there is no element, right? Union, and you understand this formula. Probability of A union B is equal to probability of B intersection B. Any doubt about this? A intersection B, right? Now this is fine. Given this, what you can do, you must know one thing called sigma algebra. Okay, although not directly, UPSC will never ask, but you must know it. Sigma algebra or Borel field. It is also called Borel field, right? What it is called? See, when you say I'm doing an experiment, let's say you rolled a dice. Okay, what can be the outcome? 1 to 6, anything. This is the sample space. Okay, and then you say the probability of coming. Let's say you rolled a dice and you got 1 to 6, right? And somebody asked what is the probability of getting 4. So what you will write? 1 upon 6.
Yes, sir.
So now see, when you study in, let's say, secondary schools or maybe undergrad course, this become very simple. But when you study probability a little bit rigorously, so you have to understand what is sigma algebra, what is probability function, right? Those things. So how do you define a Borel field or sigma algebra? It is sigma algebra is a collection of subsets. Okay, in fact, you can write the definition. A collection of subsets of S. So I'm defining it, a collection of subsets of S. S means sample space, right? A collection of subsets of S is called sigma algebra. Is called sigma algebra or Borel field, right? I'm just writing in short. Sigma algebra or Borel field, and is denoted by generally by this. You will write like this. It is not exactly B, but some, right? If it satisfies 3 conditions. What are the 3 conditions?
Empty set.
Yes, sir. Number one condition is that empty set belongs to, right? Empty set belongs to Borel field. Second condition is, I'm writing here, second condition. If A belongs to Borel field, then A complement, right? Yeah, A complement I'm denoting by A also belongs to Borel field, right? Let me, just to explain you what it means. Let's say how you can define a Borel field. Let's say I tossed a coin, so I can get head or tail, right? I can get head or tail. This is my outcome. So can you suggest me what with my Borel field?
Head,
Borel.
tail, or
What I will do, I will write my Borel field in a different color here. Okay,
yes, sir.
I'm denoting my Borel field. Yes, please tell me.
Head,
First, you will just say empty, null,
empty set.
empty set. Okay, then
Head,
only head.
or
Okay.
tail.
So you can write it like this. Okay, then tail, then head, tail.
Okay.
You got everything, right? This is your Borel field. Any problem?
No, sir.
So what?
But
What?
if you are tossed coin,
Huh?
how empty set will be?
See, empty set will. See, we assume that empty set has to be there. Let's say you did nothing. You said I have a coin. I'm doing nothing, right? Okay, got it. So you generally assume, okay, now I understand this question. If you do an experiment, then some outcome has to be there. But let's say you have a coin, but you refuse to toss it,
Yes, sir.
right? So that is again an outcome, right? Okay. Then third property. Third property you will write just a minute. If A1, A2 till let's say infinity, right? They belongs to Borel field. Okay, if these events are belonging to Borel field, then what has to happen? Union of what? These element, right, should belong to Borel field. Fine.
Yes, sir.
Any problem? Very under. See, directly you will not get. But this tells you now. Somebody now during the class. Let's say we discuss what is. Let's say I conducted an experiment and I'm choosing one element out of that. So immediately your mind will tell you from where I'm choosing, from Borel field, from sigma algebra. And how do you define sigma algebra? A collection of subsets of a sample space. Fine.
Yes.
Any problem?
No.
Okay. Now given this, now you can define probability function. Okay. Just a minute. Probability function you will define. Probability function. Okay. Just write down. Given a sample space S, that is sample space, okay?
Yes, sir.
S and its associated Borel field, right? Then the probability function has three properties. And what are those three properties? It's a simple property, right? One, that the probability has to be greater, so let's say you conduct an experiment. So the probability of that event has to be greater or equal to 0. And that makes sense, right? You did some experiment. How the probability can be less than 0?
Yes, sir.
Okay. So this is right. So, okay, I've forgotten to write this. Given a sample space and associated Borel field, then a probability function. Let's say that a probability function, P, have three conditions. Okay, and what is the domain of this probability function? And when I say domain, what it means? Let's say y is equal to x square is a function, right?
Why is the domain?
Y is the domain, right? You can put any real number, negative, positive, but your range would be only positive number, 0 or positive number. So you understand domain and range. So what is the domain of this probability function? So from where you are choosing numbers?
Probability table. Sir, Borel.
Borel Field, right? It's a what you will say, probability with a domain with the domain Borel Field, right? So, and it has to satisfy this thing. This is very simple. Then the probability of this is equal to 1. See, from class 10th, you know all these things.
Yes, sir.
You always know that probability cannot be, you always know that the probability of sample space is 1. But here you are just defining it rigorously. Fine. Third property is, see, third property is little bit controversial property. What it says, let's say there are events A1, A2 till infinity. Okay. And they are disjoint. Disjoint means, this is why let's say this is A1, this is A2, this is A3, this is disjoint, right? And you also understand what is the meaning of pairwise disjoint. When I say pairwise disjoint, what it means, you have seen the dart, okay? So this circle is pairwise disjoint from, I'm calling it circle 1, circle 2, circle 3, and like that. So all circles are pairwise disjoint. You understand? See, in probability, you have to be ready with all these things. This is pairwise disjoint, these are disjoint. Okay? So what this says, if A1,
Pairwise disjoint means every pairs are disjoint from other.
this is pairwise disjoint. Okay? So what is the third property? If A1, A2 are, this is till infinity, right? Are disjoint. And you understand disjoint, right? Mutually exclusive. Okay, then what condition would be there? Just a minute, let me see. I've done it. Yes. AI is equal to sigma I is equal to 1 to infinity probability of AI. That's correct? Yes. Okay, see what is simply I'm doing. Here I am taking the union of all these AIs, but still, and the AI are still infinity, from 1 to infinity, right? Any problem?
No, sir.
And this is what I am calling is equal to summation of individual probability.
Yes, sir.
And it makes sense as well. Let's say there are two sets. This is A1 and A2, right?
Yes, sir.
So if they are disjoint, okay. So what you can write? You can write. Can't you write this thing? Probability of A1 union A2 is equal to
Probability of
A1.
probability of
No, where is B? A2
uh,
minus
probability of A1 intersection.
B. And there is no intersection. So that would be 0, right? See, what you will do, you will write this thing as well. A1 intersection A2. But there is no intersection in this thing, right? So it is 0. So what happens? This equal becomes to equal. Just apply the same thought for infinity. So what you are doing, you are taking
A1.
So if I have to expand this thing, this formula, what I will do? Probability A1, A2, A3 till infinity, right? And this thing I am writing equal to what? Let me write it here. Probability of A1 plus probability of A2, like that, right, till infinity. So, but here is the problem. What is the problem? Problem is this: people, most of the statistician and probability theorists agree with these two, but with the third assumption, they are not in agreement. Okay, and they are, these three are called Kolmogorov axioms. What? Just Kolmogorov axioms. And he was a wonderful probability theorist, right? Wonderful professor, wonderful teacher, right? Worked very, very hard. So, and his three, where they take objection? They take objection to the, some statistician and probability theory objection to the third assumption. And what is that objection? What they say? What they are saying that you can, see, you took till infinity, right? You assume A1 to infinity. They say that you cannot apply this, if it is infinity. Let's say there are only two sets or countable sets, right? Finite set, then you can, let's say it is A1 union A2 and these two are disjoint. Then this is fine. And who mainly objected to the third axiom of Kolmogorov? This school is called Fanati school. I'm not sure if I'm pronouncing it Fanati. Okay, I think Fanati school, right? He was himself a wonderful mathematician, probability theorist, and what he said, okay, if you take the finite number, then it is fine, but if you take infinite, then it is a problem. So the Kolmogorov, the third axiom of Kolmogorov, it is also called axiom of countable right, and axiom of definitive axiom is called axiom of finite. Okay, both are additivity, right? Additivity, and same thing here. See, what is the difference? The difference is between these two words. Countable, infinity can be countable sometimes, right? So they are countable. But here, definite school side, it should be only finite. Then it is fine. So,
infinite.
See, infinity can be countable and uncountable, right? So, what Kolmogorov assume, this is we are taking only for the countable case, third axiom. But definite school, which objected to the Kolmogorov's third axiom, they said no, it should be finite additivity. Okay, what is the difference between these two? That we cannot discuss here, but yes, you understand at present that there is some difference. Fine.
Yes, sir.
This is done.
Yes, sir.
Now you understand this thing. Now, what else you can do? You know De Morgan's law. What is that? Tell me. De Morgan's probability of. See, I will write it here. Probability of. Okay, probability of A. Complement, right?
Yes.
B complement, right? This is the thing. And you will do the reverse for this, okay? You will take, in this case, you will take intersection, and here you will take a union and just put the, okay?
Yes.
This is fine. This is your De Morgan's law. This is important and you must know it. One more thing you can note down. Probability of union I is equal to 1 to infinity AI complement. Okay? AI complement is equal to probability of AI intersection, right? And this is again carrying 1 to infinity. Simply, what you have taken double complementation, right? So what you are taking union of A1 complement A2. This is complement, right? A1 A2 complement. You took the so it becomes intersection of all those. Fine. Now, given this background, what we can do? Before we move into, let's say, Bernoulli experiment and binomial distribution, let us take one question, right? So, Bayes theorem, understand, right? Bayes theorem is there, and contingency table you also understand. Let's say they are male, female, right? Some are graduate, some are not graduate. So you get a 2 by 2 table, and you can solve it, right? So you can see here the important point to remember is that when you make a contingency table, what probability you write here is probability of M intersection G. Probability of male being graduate. Here also you write probability of M intersection G. You don't, here you will not write probability of, let's say, M given G or probability of G given M, okay, or union. No. When you make a contingency table, so because see what is there.
the sum of these two probabilities. What is probability of this female intersection graduate? This has to be equal to the probability of a graduate. Okay, let's say probability of graduate is 0.6 and that probability of a non-graduate will be 0.4, right? And this sum has to be equal to 1, right? So here what you will write? Probability of F intersection G graduate, and this will be equal to 0.4. Similarly, this sum should be equal to, let's say this is 0.7, this is 0.3. Okay. Right, and let's say now you understand this thing, right? The sum of these two has to be equal to 0.7, sum of these two is equal to 0.3, and sum of these two should be equal to 0.6.
We have to get probability.
Right. See, on this concept, UPSC has asked question 3-4 times. Okay, why I'm pointing this? And let's say when I say this, M and G are independent. If I say M and G are independent, so what you can write here? Probability of M into probability of G. If they are independent, you can simply multiply. Similarly, at this place, you can replace it by probability of F into probability of not being graduate.
Yes, sir. By applying
By simple.
Yes, sir.
Okay. Now let us take one question. That question appeared in UPSC 2000. I think which year? 2017 or 18. Let me see the paper. Okay, 2018. Question number 1E. Question 1E 2018, paper 2. Numericals are, quant numericals are mainly in paper 2. What they are saying that the probability, I cannot share the paper, but I will read it. The probability that a new advertising campaign will increase sales is how much? 0.8.
Yes, sir.
Okay. The probability that the moment you read this question in UPSC, what will come to your mind? Okay, there is a campaign, advertising campaign, which can increase sale. Its probability is 0.8. So this means it cannot also increase sale, right? In some cases, it cannot increase sale. So that would be how much?
80.
In 0.80 case, they will increase sale. But in 0.20 case, it will not increase. Fine. The second, the probability that the cost of developing the new advertising campaign can be kept within the original budget, that is 0.4.
Yes, sir.
So immediately what will come to your mind? That cost cannot be within the budget.
Yes.
That will be 0.6. Okay. So assuming that the two events are independent, which two events? Campaigning, increasing sale and being within budget. See, not decreasing. Budget and sale thing are independent, right? What is the probability that the cost is not kept within budget? So what they are asking, what is the probability that cost is not kept within budget or the campaign will not increase sale? Okay, so you guys might, those who are watching lecture, they might refer this question. And let me write this. Once you read such questions in UPSC, immediately what will come to your mind? Contingency table. Although you can solve it even without contingency table. So what you will say yourself? That you did a campaign can increase sale, right? Or decrease sale, right? Any two, one of these will happen. Then it can be within budget or let's say no budget, right? No budget means budget exceed. I'm calling it no budget exceed. Okay, these two cases are there. See, if you will go with this state of mind that I will find a question like this, immediately within 2-3 minutes you will solve it. And this is a 10 marker. In 2 minutes you get 10 marks. What is so what is the probability of increasing sale? Is 0.8. 0.8. Fine. So immediately you will tell yourself that decreasing sale would be 0.2 and this is equal to 1. Then within being budget is how much? 0.4. Right? See, do not write in examination, do not write 0.4 here or write no. You have to be cautious, right? What is the 0.4? Being within budget and that has two scenarios. right?
Yes, sir.
So it will be 0.6. Fine. Now what they have given you, both budget and the sales things are independent. So generally what you write the okay, what you will write generally, budget intersection increase sale, right? Here you will write probability of budget intersection decrease sale. Okay. So but what I will do, I will indicate it by sale by S and decrease sale by S complement. Fine. And now you are given that these two events are independent. So what it means? Probability of B into probability of S. Fine.
Yes, sir.
Similarly, this is equal to probability of B into probability of S bar. Any problem?
No, sir.
So now you can write the probability. Tell me, what is the probability here? 0.8 into 0.4. 0.8 into 4. See, you are simply multiplying this. The probability of sale is how much? 0.8. Probability of budget is 0.4. So this is 0.32. Fine.
Yes, sir.
Similarly, here it will be 0.2 into 0.4, 0.08.
Yes, sir.
Okay, this is then this will be 0.48. Otherwise, how you will write it? Probability. See, otherwise, probability of, if I have to write in the function, you will write probability of budget exceed, that is budget complement, intersection sales. Here you will write budget exceed complement sales. Fine.
Yes, sir.
So here you multiply the 0.6 and here it is 0.12. And you can verify that the numbers are matching. 0.32, 0.08, 0.4, 0.48, 0.8. This is fine.
Yes, sir.
Okay, you have done. How much time it will take? Hardly 2 minutes in examination. Now they are asking what? See, once you make the contingency table, you can just from the table only you can calculate the probabilities.
Yes, sir.
Now what they are saying, what is the probability that the cost is not kept within budget? So cost is not within budget. So budget exceed, right? So this means they are interested in these two probabilities. Okay. Not cost is not kept within budget. This is, or the Campbell will not increase sale. Not increase sale is this one, right? So, and when you say or, this means case of both. So what you will do, you will simply add these three. So how much it is? 0.48 plus 0.12 plus 0.08. How much it is? 0.68, right? That is your answer. Fine. So just remember, see why I'm emphasizing on this. It is, you are going to get a question like this in UPSC into 2024, 25. In 2023 means it is bound to come every second. So go with this mindset. If I get question like this where there are two cases, I will immediately make contingency table and calculate this and just write by probability. That is fine. Okay, that's fine. Okay. Now we will move to distributions. Let me see, something is missing. What we can do. Okay, I think you can also write this inequality. See, this inequality also comes very handy. Okay, it is called Bonferroi inequality. I'm not sure I'm pronouncing it well, but this is what it is, and it makes sense as well. See, what could be the what it says? Let's say I'm writing it like this.
P of A union B is 1.
Let's say I take one here, this side. Probability A intersection B greater than probability of A plus probability of B, right? And it makes sense, as well. Why? See, what could be the maximum value of PA plus PB? 1, right? And you are adding something, So let's say there are two sides. If they have an intersection, then this greater thing will apply. But if they are wide apart, then this equality will come into place, right? It's very simple. But see, you can drive this inequality, but if you keep this thought in your mind that intersection is always, what it's saying, intersection is always greater than what? Individual probability minus 1. So that makes sense. Okay, fine. Now let's come to, there is also called things like Boole's inequality that we will not discuss. We have already discussed the 4 cases: ordered, unordered, right? With replacement, without replacement. That is fine. Now what we can do, you can write the definition of random variable. Okay, random variable. So random variable, how do you define it? It's simple,
Yeah.
Okay, how do you define random variable?
Random variable is
It's a function.
it's a
Function
changed to
which
real
maps
real values.
sample space to real values. Let's say, see, when you study probability and when we'll go into normal distribution, all those things, we will say things like, okay, x is a random variable, and I will write this formula, right? X bar minus mu, right, upon sigma x bar. I will say this is a random variable, this is population mean, and this is standard deviation. So there it is, day in and day out, we are going to talk about random variable. But how you define random variable, that is, I'm just writing a random variable. A random variable is a function. Now you will say how it is a function. We will not go into that, but yes, a random variable is a function which maps or relate a sample space. This is sample space to a real numbers, right? To real numbers. Okay. Into the function from a sample space as is a function. You can also write, let me write the exact definition which Professor Kessler-Berger wrote. So you can write a random variable function which, let me write, is a function from a sample space, as a sample space to real numbers. Okay. You can take this example we discussed, right? Let's say that you are taking a survey of 50 people.
Yes, sir.
And you are asking that one question. So the first person may agree or may not agree. Let's say somebody asks a question, whether you are happy with the present economic situation of this country. So they might answer yes or no. So they are assuming there are 50 people, right? So what could be the outcome? First person may 2 outcomes, right? Yes or no. Second person also 2, right? So this way, how many total number of outcome would be 250, right? 2 to the power 50, because there are 50 people, right? And now let's say this is a kind of a sample space. If you write it sample space, how it would look like? The first would be like nobody agreed. So the outcome would be 0, 0, 0 in every case, right? Till 0. This is one case. Now, second case, let's say this kind of cases is there where only one person agreed and other disagreed, right? So like that. I'm assuming these are 50. So, and you can position this first person at how many places? 50 places, right? Can you see? Like this. And you will place it, right? Here you will do 0, 0 first, 0, 0, 0, right? And how many cases would be like this? 50 cases. Because you can place one at, but what is happening in reality? The first, this outcome is telling you no person agreed with the state of the economy. Because let's say nobody is agreeing, you are giving it 0. If somebody is agreeing, you are giving 1. So in this case, what is happening? Only the first person agreed and the rest of them did not agree. In this case, second person agreed, did not agree. Now, there might be the case where 2 person agreed, right? So how you will write that outcome? 0, and remaining will be 0, right? Another case of this would be this 0 and next one and like that remaining 0. So indirectly what you are trying to do, you are trying to arrange two ones between 2 ones and 48 zeros.
Yes, sir.
Okay. Here what you are doing, you are see indirectly why this is 50. This is 50 C1.
Yes, sir.
Okay, you are choosing one place out of 50. Here what would be 50 C2. Okay,
Yes, sir.
and divided by. Okay, now tell me, you will divide by 2 factorial, not here.
Because taking 2% or
See, when you divide by 2 factorial, when the these are same, right?
yes, yes, yes.
So you will divide. See, okay, you have to think about. See, this is a kind of homework. You understand? Out of 50 places, you are choosing 2
Yes,
places.
sir.
Now, whether you will divide by 2 factorial or not, you have to convince yourself.
If I am not choosing divided by 2 factorial, then there is no replacement.
What you, if you are not dividing by 2 factorial, you will assume that this one and this one and this one is different.
On order.
See, let's say I can have one cake, okay,
Yes, sir.
one ball.
Yes, sir.
Both are one, right? Both are one, but they are different.
Yes, sir.
If they are different, then I will not divide by 2 factorial. But if they are both cake, right? Both are cakes, then I have to divide by 2 factorial. Simple case, right? Let's say let's say you have to look for this combination. 1, 1, 0, 0.
Yes, sir.
In how many? What is the total number of combination?
Out of 4,
Right.
4C2
4C2 upon
divided by 2.
2 factorial, 2 factorial.
2 factorial.
2 factorial, and again this 2 factorial for this one as well. Okay. So
Only 2 factorial. 4C.
Huh.
Oh, sorry. 4C2 divided by 2 factorial. Here.
sorry, 4 here what you will write?
4C2
Huh.
divided by 2 factorial.
You will write 2 factorial. No, just okay. See,
Because same numbers.
you will write 4 factorial divided by 2 factorial, 2 factorial. Okay. Again, these are basics. We will discuss it later. But see, let us come back to the main question. What you are observing here, this is single arrangement, all zeros. Here there are 50 arrangement. Here again there are many number of arrangement. But this way, how many elements would be there? 2 to the power 50. But in reality, we are what we are interested in knowing how many person did not agreed at all. So what was the case in which no person agreed? This case was only one, right? In how many cases, one person agreed? Okay. How many cases are there?
50 cases.
50 cases, right?
Yes.
So we are more interested in these numbers, right? So this is what now you understand what is the meaning of real random variable. It is mapping a sample space onto a real line. So it's will be 1, 2, 3 till 50. Why? In the first case, no. Let's say I'm interested in person agreeing. In the first case, anyone agreed?
No.
No. In the second case, although there are 50 cases, but how many person actually agreed?
1,
Only one. In this case, how many person actually agreed?
2.
Again, there are many cases. So generally, we are interested in this kind of outcome. Okay. So so this is what you have to remember. Fine. So this gives you. Now we will move into your random variable is done, and let's say you can write an example of a random variable. You toss it dice. Okay.
Yes, sir.
So what can be the outcome? 1, 2, 3, 4, 5, 6, and that is defined by random variable x. Fine.
Yes, sir.
Now let me see what else we can do.
I think now we can move into binomial distribution and Bernoulli's. Okay.
You know probability mass function, probability density function. Probability mass function, you know, for probability mass function we use when it is a discrete case. Probability density function we use when it is a continuous case. Let's say a continuous. For example, normal distribution is a continuous distribution. Probability mass function in the binomial distribution, that is a okay. And you know expected value.
Yes, sir. E of x equal to f of x.
Yes, you know, you can write the formula. Let's say gx is a random variable. Okay, what is your random variable?
E of x.
So its expected value would be given by. Tell me how much? Sigma. Right.
Sigma internal.
Gx, fx, and this is your PDF. Let's say this is your probability density function, right? So px, x, see, when you write, you have to be careful. Now you cannot see what this x is. X is capital X. That is for random variable. Can you see? This also is a function of a random variable. But what value it is taking, that is small x. What I mean to say, let's say I'm defining a random variable as the outcome of dice, right? So what could be my and this x, small x could be the outcome. And so what could be my outcome? 1, 2 till 6. So be careful. Small x could be 1, 2, 3, 4, 5, 6. So when I'm writing a notation that I defined this random variable. So this x is capital X.
Yes, sir.
Because it denotes it is a part of random variable. Okay. See, I'm calling it, this is a random variable.
Yes, sir.
So this is now what I'm doing. I'm calculating its expected value. Expected value, you know, mean, right?
Yes, sir.
So what I did, I'm taking a summation. I will take summation in the case of discrete. So gx into probability mass function. This is your.
Sir, is this PDF or PMO?
This is PMF.
Yes, sir.
This is a discrete case, right? We are talking first about this discrete case, and this is your random variable, right? Now let's say it is a continuous case. Then what you will do? See, let's say I have to add you know, in the basic calculus, how you calculate area. Let's say this area you have to calculate, right? You will integrate this area. Let's say I'm assuming the area is like this.
Yes.
It is going to infinity, and here also it is going to infinity. So how you will calculate this area? You will integrate from minus infinity to plus infinity. Same way we are doing. Minus infinity to infinity. That random variable gx, it's a PDF, probability density function multiplied by dx. This is the way you calculate
Yes, sir.
what expected value. Okay, fine.
This side is the random variable. It's the
See, this is your expected value.
yes, sir.
In the case of discrete, this is your when the function, you know, it is discrete case, it is given by summation. Okay, because see, why summation? In discrete case, you assume the mass is there. You can add them, but in continuous case, you assume at one point there is no mass.
Yes, sir.
Right? It is distributed according to some function, and how you calculate that expected value? Integrating minus infinity to infinity, or with the range. Let's say the function is like this, from 0 to 5. So here you will integrate from 0 to 5.
Yes, sir.
Fine, and this is your random variable multiplied by PDF into dx. That is fine. Okay.
Yes,
Now we will move to Bernoulli and binomial distribution, which is very important again for UPSC. What happened? First, you have to understand Bernoulli trial. What the Bernoulli trial says. Let's say I'm conducting an experiment which can have only two outcomes and which are mutually exclusive. Let's say somebody asks me question like this: whether you agree or disagree with the present state of economy. I will say yes or no. Okay, no, nothing in between. I toss a coin. it can be head or tail, nothing in between, either head or either tail. So when there are only two outcomes and this experiment is there, then we will calculate the probability and its variance. You know what is variance, right?
Yes, sir.
Variance formula, variance of x will be given by, tell me, sigma
X
xi
plus
x bar, this is mean whole square upon n, right? And you can also write it like xi square upon n minus x bar square. Fine. This is important. This is the way, and let's say standard deviation, you will just take a square root. And can you also tell about covariance? Let's say I have to write the formula of covariance xy. So what? Summation of
xi minus x bar
wonderful
yi minus y bar
yi minus y bar n. Wonderful, wonderful, right? And you can expand this formula. How you will write? Sigma xi yi upon n minus x bar. No, y bar, not whole square. See, there is not much. Let's say variance. I can also write covariance of x comma x. There is no difference between variance and this thing. So see this formula. Try to see this formula, this formula. Here what I have taken, rather than 2x, I have taken 1x and 1y. So I am just simply, let's say I take a square and at another place I write y minus y bar. Here also now compare this formula with this formula. It is very, xi square here, xi into yi, x bar square and this thing. Fine. Now you must also know how we got from this formula to this formula. Can you prove that?
Yes, sir.
Tell me how you prove that.
For a xi minus x bar, we are substituting the formula xi
See,
minus
why I'm emphasizing on this? In UPSC, when you will do regression equation order, you will use this formula 99% of the time. Because it is very calculation handy, easy to calculate.
Yes, sir.
Okay, when you will calculate correlation coefficient or beta, right? Let's say there is a regression equation. Y is equal to beta naught plus beta 1 is slope, into x. This is your dependent variable, right? This is an independent variable. And this is your regression equation. And you have to calculate slope. Okay. So how you calculate beta 1? Covariance xy upon sigma x square. Okay. So when calculating covariance or this variance, you will use this formula most of the time. Or similarly for covariance, which formula you will use? This one. Just now we wrote xi yi upon n minus x bar into y bar. Fine. So remind yourself that in examination scenario, I am going to use in UPSC mains this not only for management, also for the statistics optional. Both. Fine. Now let us prove it. Tell me.
By simplifying this, we can get that, sir. Substituting xi minus x bar whole square equals to
I'm just
xi minus xi square minus 2 into xi x bar
square.
minus 2 into xi x bar.
Okay. Now we will just open it, right? And this is by n. So it would be equal to sigma xi square upon n. So we got the first term. See what we have to do. We have to prove this thing being equal to this, right? So now we expanded it and we got the first term. Now coming to the second part, plus sigma x bar square upon n, right? And minus 2 sigma xi x bar upon n. Fine.
Yes, sir.
Now what you can do with the xi?
Remove the x bar also.
Okay. So how can you write this term? You can write it 2 x bar n xi, this is small, right? Xi upon n. Okay, this is fine, right? 2.
Yes, you apply the
Right, for summation.
You
Yeah.
apply it.
Right. Here also you will have, just a minute. Let me see. X by xy square, this is fine.
We take the x bar outside.
No,
In the other step.
that is fine. But we are applying it 9 and n times. So this is fine. 2xi. Okay. This is x bar. And x bar. Okay. See, now see this thing. Okay. Now try to understand this thing. If I'm writing x1 plus x2 till xn, right? Can I write also equal to n into x bar? Any problem?
No.
Because see, let's say this is my series is there. Right? I'm just multiplying mean with the n.
N number.
So when you can write it like now these two terms, right? This term and this term. How you can write? X bar square minus 2 x bar square. Okay, this will this is equal to this, and this right. You will take summation. You will take n times, so n will get cancelled. Okay, because it is n times, right? So n get cancelled. This thing, and when you take x bar square minus 2x, you will get this thing. Okay. So in examination, you do not have to prove all this, but yes, here you have convinced yourself why this formula is equal to this formula, and this is what you are going to write using UPSC mains. Fine.
Yes.
Now, and similarly, you will prove it for covariance, simply expansion game.
Yes.
Now we will move to Bernoulli's trial. So what we said in Bernoulli trial, what we do, we conduct a trial in which there are only two outcomes. And let me say, I'm calling, if I get head, I will denote it by 1. If I get tail, I will denote it by 0. And the probability of getting head is P. So the probability of getting tail would be 1 minus P. Fine.
Yes.
Now let me, I am interested in two things. One is mean and the variance of this experiment, this trial. Okay.
Yes.
Now tell me, what would the mean?
Mean is 1 by 2.
No, why?
Mm.
See, how do you calculate mean? Let's say there is a x is there, probability is there, right? 1, 2, 3, 4 like this, and their probability is 0.3, 0.2, 0.3, 0.2. Okay. What you will do, you will just simply multiply expected value. That is mean. Here, what is the, if so, your mean would be,
1 of P.
I'm calling it expected value of this experiment would be 1 of the outcome into its probability, right? Second is 0 into 1 minus P. So see why I'm taking trial 0. What I'm trying to do, let's say I conduct a trial. I'm interested only in success. Let's say I'm betting on something. So I'm more interested if I get head. So to head, I'm giving 1.
Yes.
So it might be other way around as well. You can give 1 to trial, then head to 0. It depends upon how you define success. If you define success by head, then it is fine. So you know what is the expected value in the Bernoulli's trial? P.
Yes, sir.
Now variance. Now what will be the variance of this experiment? Variance would be given by, tell me.
Variance 1 minus.
You know the formula.
P.
Xi minus x bar whole square upon n sigma. Okay. Yes. So here, what is your xi? 1 is 1. Okay. 1 minus what? Mean. What is the mean? See, coincidentally here, your mean and the probability of head is also same. And it has to be because you are have given 0 to tail. You are putting, you are giving, your payoff is only through heads, not through tail. That's why your expected mean and this is same. So 1 minus, this is xi minus x bar into its probability. What is its probability? See, now you convince yourself. When I write this P, multiply with, I'm using this. When I'm writing this P, I'm using this. Okay. Coincidentally, here both things are same. Then second part, your tail. What is the payoff of tail? 0 minus the minus expected value, right? Expected value is again P into its probability. So what this value is? Tell me what this value is? P.
So can you explain what is
See, variance is nothing but xi minus x bar into its probability. See, what we do, if let's say everything is uniformly distributed, then we simply divide it by n. But here the things are not uniformly distributed. The probability of head is p, probability of tail is 1 minus p. So what we are going to do, difference, this xi minus x bar, we are going to multiply with their individual probabilities. So that's what I have done. 1 minus expected value into its probability, 0 minus expected value into its probability. Fine? So I'm just expanding it. P into 1 minus p plus what? What would be? P into 1 minus p minus p 1 minus p. Okay? And how much it is? ये कैसे हो गया? 1 minus expected value its probability, 0 minus expected value. Okay. We made some mistake or what? Oh. We have not taken squares. Okay, right? Without square, how you will calculate variance? Okay, so this is square and here 0 minus p square. Okay, this thing you have to keep in mind. Fine. See, this difference ka square you have to take. What is the formula? What xi minus x bar ka whole square into, this 1 by n is there, right?
Yes,
Let me write it like this. Okay.
sir.
So now you see, you have to understand. Let's say if the numbers are uniformly distributed, then we simply divide it by n, because we assume all numbers are uniformly distributed. Let's say there are 1, 2, 3, 4, 5, and everyone is occurring 20% of the time. Then you will simply divide it by 5. But here 1 is occurring, let's say, by 40%, b by 10%. Then you have to multiply with their individual probability. So that's what I have done here. 1 minus p ka whole square into p, 0 minus p ka whole square into 1 minus p. Fine?
Yes, sir.
This is variance formula, nothing simple. Okay, now I have written it here. P into 1 minus p square into, this is p square into 1 minus p. Any problem?
Yes, sir.
Now simply take 1 minus p common. When you take 1 minus p common, what you get? You can take p into 1 minus p common. P into
1 minus p.
p common, right?
Yes, sir.
So here you will get 1 minus p, okay, plus p, right?
Plus
P. This is fine. So from here you got p into 1 minus p, and this is what we were looking for. This is the variance of what? Bernoulli experiment, and this is very, very important. So what you have understood so far, when you conduct a Bernoulli experiment, its expected mean is p and its variance is p into 1 minus p, where p is the probability of success of hat, right?
yes, sir.
Now given this background, now you can conduct a binomial experiment, and binomial is important for UPSC. Let's say there was a question. It was in, I think, 2000. Which year? 2010 or what year it was? Yes, 2010, I think. Yes. Not 10 or 13. Let me see. This came in 2013. Question number 1A.
2013.
Yeah, it was a question on no, this is question. That regimen question is which year? This is 2013 is your let me see that question. I think 2011 it was there. Not even 2011, so maybe 2010
10 it should be. Initially, I told now, just please note down two questions. Okay, 2009, yes. It is the question came is 2009. Question 1A. Question 1A. It is a question on regimen. I'm just reading a question. What it says. A regimen means medicine. Okay. Consisting of a daily dose of vitamin C was tested to determine its effectiveness in preventing the common cold. Let's say you are giving you are giving some medicine to determine whether it can prevent cold or not. 10 people who were following the prescribed regimen were observed for a period of 1 year. 8 survived the winter without cold. So you gave this medicine to 10 people. Okay. And 8 survived the winter without cold. So out of 10 people, 8 survived. That is fantastic. Suppose the probability of surviving the winter without cold. Suppose the probability of surviving the winter without cold is 0.8 when the vitamin C regimen is not given. So let's say there is no medicine. Even then, out of 10 people, how many will survive? 5 will survive because it is given probability 0.5. What is the probability of observing 8 or more survivors? What is the probability of observing 8 or more survivors given that the regimen is ineffective in increasing its resistance to cold? So what is the story? There is a medicine, right? Regimen means medicine, doctor writes regimen. So what this they gave this medicine to 10 people and 8 of them survived the cold. So in this particular case, out of 10 people, 8 people survived. Let's say there is no regimen. There is no regimen. So generally, how many people will survive? 5 people, because probability is 50%. If there is no medicine, then 50% people will survive. Then they are asking what is the probability of people surviving 8 or more than 8. Let's say probability of right. Okay. So this is fine. But in the last line, what they are saying, suppose the regimen is ineffective. Okay. So what is the meaning of a regimen is ineffective? So that is fine, effective convenience. But what probability you will take? You will take 0.8 or 0.5? See, what you will take 0.5 because they have said the regimen is ineffective. So when the regimen was not given, out of 10 people, how many survived? 5 survived. Okay, out of 10 people, 5 survived. And but in the first case, what they observed, out of 10 people, 8 survived. So that kind of a placebo effect, placebo effect, right? So this is what now here comes the importance. So what you are looking for? You are looking for 8 success, 8 or more success out of 10 people. Fine. In such questions, your binomial distributions come very handy. And how binomial distribution is derived? Through this thing. Just tell you formula. What is the formula of binomial distribution? It says, let's say you are looking for x success, x number of success, right? So how it is given? NCx into probability of x upon 1 minus p and minus x. Just to tell you what is it? You did that trial n times and you are looking for x number of success. In this particular case, so what is n? N would be 10 because there are 10 people. And you are looking for how many success? 8, 9 or 10. Just let us assume your x is only 8. You are looking for, so then you will write it 9, C, 8 into probability of success. What is the probability of success? Here success means surviving cold. No. Probability would be 0.5. Right? Because when no regimen was given, so how many people survived the cold? 50%. And in the last line they have said the regimen is ineffective. Right? It is ineffective. So what probability you will take? The same probability the number of people survived when no regimen was given. This is fine. 0.5 power 8. Here 1 minus 0.5 power, that is 2.
This is for only, see, when you use binomial distribution, it gives the probability of exactly 9 x success out of n trial. But here you are looking for probability of 8 or more than 8. So your answer for this, I'm just writing it here. This should be equal to, let me write it here. Yeah, next page we can go, but what I will do, probability of x greater than 8. This is equal to probability of x is equal to 8 plus probability of x is equal to 9 plus probability of x is equal to 10. These three cases we are interested in. Fine? Because either 8 people, 9 people, or 10, right? And you know what is the formula of 8. Similarly, you calculate the formula for 9. And yes.
8 into 0.5 power
8
into 1 minus 5 power 2.
Right. And
plus 10C9.
okay, yes, that's fine. Okay, this way you will write, and you have the calculator, and you will immediately calculate it. Fine. Now, the most, see, this is if you know this much, you will definitely get 10 to 15 marks in UPSC. We will discuss one more question which appeared in I think 2016 or 17. But how you get this formula? UPSC will never ask the derivation, but you must know that, you must have this understanding. How you got binomial distribution? How you got this formula? Okay. What is the expected mean of binomial distribution? What is the variance of binomial distribution? These are things you must know. Fine. So let me start. See how you define a binomial distribution. When you conduct the Bernoulli experiment, and what is Bernoulli experiment? We saw just tossing a coin, n times. When you conduct Bernoulli experiment n time, it is called binomial distribution. That is binomial distribution. This is very, very important for UPSC. Okay. So let's say I did the experiment n times, and I'm looking for x number of success, and I'm defining my success as the coming head. If I get head, it is a success. So, and what I just mentioned, that this success is, what is this probability? This probability is given by NCX, probability of x upon 1 minus p n minus x. So you have to convince yourself how this formula came. Let us assume this is 50, right? This is n times. So I'm calling success, I'm assuming that my head came. Yes, binomial distribution means when the Bernoulli experiment is conducted n times. And its assumption and everything, I think, right, we will discuss that. See, what is its assumption? First assumption is that there are two outcomes of the experiment. Either head, tail, yes, no, like that. Outcome in one trial is independent of a second trial. So let's say you got head here. So it has no bearing on what you will get on this. So here also the probability of getting head or tail is equal. Right? These two assumptions are very, very important. Fine. Now you conducted this experiment and you are assuming that you got head n times. Okay, I'm calling it x times. Because you are looking for x number of success. So remaining time what you will get? Tail. Right? I'm calling it n minus x. Fine? Because the total number of trial is n. Now, you see, you were interested in x number of success. These x things can itself be arranged in many ways. For example, let's say I got I'm just assuming there are only 4 trials. I'm looking for one success of head. So this will be one case. Another case could be tail, head, tail, then tail. You got the point, right? You can arrange this head in 4 places. So do you observe this outcome itself can be arranged in a number of ways. And what is that number of ways? Out of n places, you are choosing x places, right? There are n places total, and your x is x number of his head. So what you are just doing, arranging these x at the 9 places, sorry, this n places. So this is the number. This is the number of arrangement. This is fine. So this convince you, okay, from where we got this thing. Now convince yourself of this part. Let's say the probability of success is what? Probability of success is P. So every probability would be what? This probability would be P, this also P, this also P, right? And all these probabilities are 1 minus P. Because they are failure. They are not success. So what will the total probability of this outcome? That would be P to the power X into 1 minus P to the power N minus X. Got it?
Yes, sir.
So simple, let's say this is an outcome, its probability is this, and this can be arranged in how many ways? MCX way. That's why your binomial distribution probability is this. This is a very logical argument, and you are convinced. Fine?
Yes, sir.
Now, see, remember this here. This is very, very important for UPSC. You will get 10-15 marks out of here. Now, let me say what is the expected value of, I know the expected value of, in the case of Bernoulli was P. And the variance in the case of Bernoulli was P into 1 minus P. Which case? Bernoulli experiment. Bernoulli experiment. I've forgotten the spelling of Bernoulli. Binomial distribution. Binomial distribution. Your expected value is given by NP. And your variance is given by N into P into 1 minus P. Fine. Now you have to convince yourself. See, there is one proof that we will do. But convince yourself why this is true. Let's say what you did in Bernoulli experiment. Simply one thing, and if you got ahead, you called it success.
Yes, sir.
Now, let's say what you are doing in binomial experiment? N times that thing. So, can you write it N into P? See, to give you an example, let's say the probability of head is 0.4. It is a biased coin. Probability of head is 0.4. And I do it one time. So, what will be my probability? 0.4. Let's say I do it 10 times. So, what is the chance that I will get head? 4 times.
Yes, sir. Okay.
So, how you got 4? 4 you will get 10 into 0.4. That is 4, right? Because you did experiment 10. See, what is the meaning of binomial distribution? Doing that Bernoulli trial n times. So, this is 10, this is P, you got 4 here, and this makes, this convinces you why in binomial case you can multiply by n. Now come to this part, variances. How do you define variance generally? Let's say I say variance of x plus y. It is defined by variance of x plus variance of y to covariance x comma y. Okay, this should be x. Fine. This is the way you define it. And how you define covariance? Covariance, you say covariance xy is given by, tell me. Okay, either you can write like this: sigma x, sigma y, correlation coefficient. Okay, this way you can define. So from here you can replace this thing by, see, you can replace this thing by 2 rho, this is a correlation coefficient, into standard deviation of x into standard deviation of y. Fine?
Yes, sir.
Any problem?
No, sir.
Now, given this thing, generally, see, if they are independent, let's say I say x and y are independent, then what will the correlation coefficient? Correlation coefficient will be 0. You know, correlation coefficient vary from, what correlation coefficient gives. If the x is changing, how the y is changing. So let's say it is it varies from -1 to +1.
Yes, sir.
It varies from the value of correlation coefficient varies from. See, don't worry, in regression, when we will study regression, you will, study rigorously, but for the time being, this value vary from -1 to +1. If x and y are independent, and which is what we assumed in Bernoulli. So, binomial distribution, that the two trials of binomial distribution are independent. So, we will take this part to be equal to 0. Fine. So, these variances would be additive now. If these variances are additive, So it becomes very convincing. What was the variance of one Bernoulli trial? What was the variance of one Bernoulli trial? P into 1 minus P, right? And what is binomial distribution? Doing that trial and times. So you are simply adding it, or you can write it like this as well. The variance of, let's say, binomial distribution would be x1 plus x2 till xn, right? And you are assuming x1, x2 and all these are independent. This is our assumption. So simply you will add variance of x1 plus variance of, so variance will become additive till variance of xn. And what is the variance of all these experiments? P into 1 minus P. So that's why the variance become n into P into 1 minus P. Fine. Very, very logical and very simple description. But very, very important. See, without this understanding, this foundation, if you will move into exponential distribution, normal distribution, and hypothesis testing, confusion would be there.
Yes, sir. Variance of x number of n number of extremes equal to n.
See, this is nothing but the binomial distribution. And these are Bernoulli's trials.
Yes, sir.
How you define Bernoulli trial? By an experiment. Fine.
Yes, sir.
Okay. Now, let us do one more proof. Let us calculate the expected value of Bernoulli experiment by another formula. Just now, binomial distribution, is a discrete distribution. Okay? And I am trying to calculate its expected value. Now tell me how you will do that. Let's say just now we saw how it is given. It is given by nc x p to the power x 1 minus p to the power n minus x, where x varies from 0, 1 till n. You know this part? Any doubt here? This is what you know? And okay, now how you define expected value? In discrete case, we saw summation of that variable into its PMF. What is PMF? This is a PMF. This is probability. See, let's say why I'm calling it PMF. Let's say that you did 10. Take the regimen wala question. If you're looking for 8 success, so some probability is distributed there. If you're looking for 9 success, some probability is distributed there, right? For 10 and similarly for 1 true, some mass. So these are nothing, and if you add all these, you get 1, right? Like that. So here, what you will multiply this probability mass function, and what is the probability mass function? NCX p to the power x into 1 minus p to the power n minus x. Fine.
It's PDF or PMF.
It's a discrete case. In discrete case, what you will call it? PMF.
Yes.
In continuous case, you will call it PDF.
Yes.
Any doubt here?
Yes, sir. No, sir.
Now, just we will do some algebraic manipulation here, and then it would be you will see what is the objective. We have to prove that this thing is equal to NP. No.
Yes.
See, there is one binomial kind of inequality. It is written by is equal to n c n minus 1 x minus 1. Okay. Why? See, this thing you must know.
Yes, sir.
Okay, and how you can prove it? And it's simple, let me do it. N factorial into n minus 1 factorial. I'm simply expanding this thing. Okay, to be more simple, I will write it like this. N factorial upon x factorial into n minus x factorial. This is fine?
Yes, sir.
Now I can write it like x into n minus 1 factorial upon x into x minus 1 factorial, right? And this is your n minus x factorial. Fine?
Yes, sir.
X got cancelled, right? X got cancelled. Then you can write it, right? You can write it n minus 1 into x minus 1. See, why? See, now this n is there, right? And this is nothing but, see, now I'm expanding this. You see n minus 1 factorial into x minus 1 factorial, n minus 1 minus x minus 1 would be n minus x factorial. Convinced? Now, any problem with this inequality? You will simply replace it there. Now, what you will do? See, you aspirant must know this directly. UPSC will not ask, but when you know all these results, it becomes very, very handy. So, what I can do? I can write n sigma n minus 1 c x minus 1 p x 1 minus p n minus x. Fine.
Yes, sir.
Now what you can do, n is a constant and you can take outside. Okay, and you can assume that x minus 1 is equal to y. Let us assume y is equal to x minus 1. And let me change it. What I will write? N sigma n minus 1 is fine. X minus 1 is, I have assumed y. Okay, limit will also change. No? X is equal to 0 to n. Here it was x is equal to 0 to n. So it will become x is equal to 1, not 1 to n. Here it will become x is equal to y is equal to 0 to n minus 1. Right?
You are substituting x minus 1 equal to
Y. I'm just changing this right limits. So here it was x is equal to 1, it become y is equal to 0, and will become n minus 1, right? And this is, I replaced x minus 1 by this thing. And here at the place of p, I will write what? Y plus 1, okay? And at the place of 1 minus y, I will write n minus y plus 1. Any problem? Fine. Now, what I can do, see, I can write it again. I can write it p q power y into p, right? And that p I can take outside because p is constant. So, sigma y is equal to 0, n minus 1, n minus 1 c y, p to the power y, 1 minus p to the power n minus 1 y. Okay?
yes, sir.
And nothing, I've simply taken this y outside and everything is fine. Now you have to convince yourself that this thing, okay, what I'm saying, this expression, okay, and this expression. What expression?
Sir, p power y plus 1.
So that one p I have taken outside, na? P to the power y into p you will write.
Yes, sir.
So p I have taken outside.
Yes, sir.
Okay?
Yes, sir.
Any problem?
No, sir.
Then this is fine. Okay. Now, see what I'm trying to say. You have to convince yourself that this thing. Okay, just tell me this thing. Let's say I have this expression is equal to 1 to n cx p to the power x 1 minus p n minus x. What is the value of this number, this summation?
1.
Why 1? Because it is considering all the cases. Let's say take the case of regimen. If I calculate from, n is equal to 10, x is equal to 1, n is by 10, c is equal to 1, c 2, I add all the cases. So here I am adding all the cases. If I expand, for 1, 2, 10, till n. So, and we know the basic foundation of, when we define the probability function, what we said, probability of S sample space has to be 1. You remember Kolmogorov axioms? What was the second assumption? So this thing has to be equal to 1. And now convince yourself that this expression and this expression are not different. Why? See what is happening here.
Instead of x equal to 1, y equal to
0. Y is equal to 0 and this n is varying from n minus 1. See,
it looks, it is the same thing, just written in a different form. What is happening? X, here limit is varying from x is equal to 1 to n. Here it is varying from 0 to n minus 1. Here n is replaced by n minus 1, x by y, and here again, see, you can call it, let's say this n minus 1. Again, you can do, let's say algebra. Let's say I'm calling it capital N, okay? And this is a capital N, and this is capital N. So this capital N is nothing but this capital, okay? Same thing. This is also equal to capital N. This is also equal to capital. Now you say it. Fine. So this is also equal to 1. This is also equal to 1. So that means your expected value of binomial distribution has to be NP. Fine. See, wonderful proof. Simply you have to remember two things. One, you must know how to write the summation or how to write the expected, this random variable into into PMF, and then you have to do binomial. You must know that binomial inequality, right?
Yes, sir.
Convinced?
Yes, sir.
Okay. Now, what you can do? Let me see one more thing. Now there are things like moment generating functions, MGF. Those are not in UPSC syllabus, but for statistics optional I will teach them. Okay. What is moment generating function? Moment generating function is simply, let's say there are some moments.
Yes, sir.
Right? Let's say variance is your moment, mean is your moment, right? Your skewness, kurtosis. Kurtosis, you understand?
Huh?
Kurtosis and skewness.
No, sir.
Let's say this is not normal distribution, okay? This is an skewed. ये थोड़ा skewed नहीं बना. Okay, yes. Okay, why I'm not able to draw it? Just a minute. This is a normal distribution. Okay. Now let me draw it. This is your kurtosis. Kurtosis. This is your fourth moment generating. Okay. Your third moment generating function is this is your skewness. Can you see the area is concentrated on the left hand side? Kurtosis, what is the height is very high. Okay, at the mean, most of the mass is concentrated at the mean compared to normal distribution. This is your normal distribution. Okay, all these are normal distribution, but this is with high kurtosis, this is with skewness. So all these come through moment generative function. And what is MGF and all those things? I think for management optional we should not teach, but for statistics optional for UPSC, that is required. Fine. Now let me see. Okay, what else we can do? Moment generating function. Okay. Although it is called moment generating function, but it generates nothing. Okay. So that is a funny name. See, you call it random variable, but when you read it exactly, you find it is a function. Here you call it moment. See, the things like it's generating something, but it is generating nothing. Okay. Now
It's not in the
it's all, but yes, it is proof and all those things is not there, but its outcome is in syllabus. Let's say you must know kurtosis. What is skewness? Okay, what is variance? Variance you already know. So I will say how what we'll do in the next class we will define. What else we can? Okay, variance of is remaining now. Variance of binomial distribution. How the variance would be given? Tell me. Variance is given by expected value of x square minus expected. Fine. Sorry. Yes, sir. Okay. Okay. Just a minute. This is fine, na? See what is okay? You're confused. No problem. See what I'm writing. When I write ex, what it means? It means x bar. When I'm writing ex square, it means you are taking the expected value of
X.
You got my point? Ex whole square. This is same as let's say just
earlier we wrote the formula xi minus square upon x bar ka whole square. So this is nothing. X bar is expected value, and this is you are taking the squares and just calculating their expected value. So this formula and this formula is same, just a different way of representation. Fine.
X bar you are writing reverse order.
No, I'm not writing in reverse order. I'm writing in the same order. You know, this thing is equal to this, and this thing is equal to this. What is the meaning of EX?
The second equation, sir.
Second equation, what is the problem? Same thing, na? Same thing I've written.
Same thing.
Here also you can apply. What is the problem?
Yes, sir. Now I got it.
Same. It's the same formula. All three of them are same formula.
Yes.
Okay. Here, what you are doing, you are taking the square of the expected value of x. Here, you are calculating the expected value of x square.
Yes, sir.
Right? XC. What you do here? You take the squares of x and you calculate their average, and then you subtract. Subtract from it x bar ka whole square. Now, what my point is? Let's say you have to calculate the variance of binomial distribution. You know what is the formula?
Yes, sir.
Tell me.
Binomial distribution
Is n into p minus p into
1 minus
p. You already saw, and how we visualize it. How we visualize it? That binomial distribution is nothing but the n times of Bernoulli experiment, and Bernoulli trial gives you p into 1 minus p, and you are doing it n times, and that's why you will add it n times. You assume that all trials are independent, but can you prove it? Let's say using this formula. Now, expected value you've already calculated. What is the expected value of binomial? NP. So this thing you already know. Let's say somebody you get this value. So then you will simply get the variance of binomial as well. How you can define this function?
NP
Tell me. Sigma
x
square, right? Into PDF, right? Sorry, PMF. What is PMF? NCX P
power x 1
minus P
power n
minus X. Okay. Now, and X is varying from 1 to N.
We are solving these
Now, see, you will solve this expression. See, here you are using X square because you are calculating the.
binomial equation.
This is nothing but the PMF of binomial.
Yes, sir.
This is probability mass function. You are calculating. See, you are calculating expected value of something, and what is the random variable? X square. So you wrote that random variable here, and you multiplied it with the PMF of binomial. This is now you will solve this expression, and whatever the value will come, you will put it here and subtract it from NP square, and that will give you n into P into 1 minus P. Right? Now we can solve it here, but you guys can take as let's say homework, right? So see again here also you have to use this inequality or this binomial. What? N x minus 1. Sorry, n minus 1 and cx n minus 1 x minus 1. Okay. And cx. Just now we use this inequality only, right?
Yes, sir.
So this one you.
This is also equal to that same one.
Yes, sir. Just now we saw it, right?
Yes, sir.
So you will use it and you will plug it in this and you will prove that this is equal to this. This is your homework. In tomorrow class we will discuss.
This is equal to that.
See, you will solve it. You will get some expression in the form of NP, right?
Yes, sir.
Let me tell you what the expression you will get. You will get expression like n into n minus 1 p square plus np. This is the expression you are going to get. And let me check it once again.
Yes, sir.
And
I'll take the NP common also.
this expression you will get, and you from this expression you already got np square, right? Expected value of here. So what I'm trying to say, just a minute. This thing, when you will solve it, you will get this thing, okay? And from it you will subtract what? NP
Into 1 minus
NP square, right? N square into, and when you will solve it, you will get n into P into 1 minus P. That is the variance of binomial. This is your homework, right? You will solve it, and tomorrow we will discuss. Okay, so we will wind up for today.